Welcome back, students, in a new video where I'm going to discuss about sound. So in this chapter, we are going to understand about what is sound, how sound produce, how sound travels, the propagation of sound, wave and its kinds, reflection of sound, echo, types of vibration, and characteristics of sound. Now, sound is not a new thing for you all. You had studied about sound in your previous classes also. But the things which we are studying over here, or we are mainly focusing over here, that is the wave and its kinds. And else than this, all the topics which we are going to discuss, mostly you know about it and you had studied in your previous classes. So let's start with this. So first of all, we need to understand about sound. So let's take a little recap of the thing what we had studied in our junior classes. So sound, when we come for in physics or when we define it in physics, then we can say that it is an acoustic wave which used to cause or which used to form due to vibration in a body and can be transmitted in any kind of medium, whether it is a solid, liquid, or gas. So when you hit a body or when you cause vibration in a body, then that vibration leads this sound to form over there by moving the particles ahead or by making the particles vibrate in the forward direction. सो जब हम लोग साउंड के बारे में बात करते हैं तो साउंड बेसिकली है एक तरह का एनर्जी. साउंड को हम लोग डिफाइन कर सकते हैं एक तरह का एनर्जी जो कि काउज होता है ड्यू टू द वाइब्रेशन इन बॉडी. तो जब भी किसी भी बॉडी को हम लोग हिट करते हैं और उसमें वाइब्रेशन होती है तो वो एक एक्वेस्टिक वेव क्रिएट करती है जो कि किसी भी मीडियम मटेरियल मीडियम से ट्रैवल कर सकती है और वो एक एंड से दूसरे एंड तक जब ट्रैवल करती है तो साउंड का कैरी ऑन होता है. तो अलग अलग एग्जांपल्स हम लोग देख सकते हैं साउंड के बारे में. तो जैसा कि हम पहले ही बताए हैं कि ये एक ऐसा टर्म है जिसके बारे में हम लोगों ने क्लास 6 से ही पढ़ना स्टार्ट कर लिया था इन अ डिटेल्ड फॉर्म. सो तुम लोगों को बेसिक नॉलेज जो है साउंड के बारे में है, तो उसके ऊपर हम लोग ज्यादा टाइम वेस्ट नहीं करेंगे. अब हम लोग नेक्स्ट आ जाते हैं जो हम लोगों को समझना है, दैट इज द प्रोपेगेशन ऑफ साउंड. So when we come for this propagation of sound in a simple language, we can say this thing that sound needs a material medium to travel. And this property of the sound is called the propagation of sound. So when sound is traveling, when the sound is allowed to move from one end to another end, as I said that it requires a material medium. So why do it requires this material medium? So when we come across, then we know for this thing that sound used to be traveled due to causing compression and rarer fraction in the molecules or among the molecules, and due to that only it is transmitting the energy from one end to another end. So when we see for this compression and rarer fraction, this is actually the condition of the movement of the particles. So say as for example there are particles over here. Say as this is A particle, this is B particle, this is C particle, here it is the D particle, so on and on. There are so many particles over there. So the arrangement of the particles in a given medium depends on the density of that particular medium. But you know for this thing that when we see for a solid, liquid, and gas, then the arrangement of the particles used to be different. But when we observe the phenomena, then the phenomena works in the same way. Either we are talking about for a solid, liquid or gas. तो यहाँ पर compression और rarefaction को हम लोग को समझना है, जिसके बेसिस पर हम लोग ये कहते हैं propagation of sound होता क्या चीज है या propagation of sound कैसे काम करता है. तो जैसे कि यहाँ पे हम बताएं कि मान लो कि यहाँ पे 4 पार्टिकल्स है, किसी मैटर के ये 4 पार्टिकल्स है. तो यहाँ पर हम लोग इन पार्टिकल्स के एक बिहेवियर को समझने वाले हैं कि जब हम लोग वाइब्रेशन क्रिएट करते हैं. वाइब्रेशन क्रिएट करने का मतलब क्या हुआ, जब हम लोग एनर्जी सप्लाई करते हैं. तो सपोज मान लो कि ये ए पार्टिकल है, ए पार्टिकल में यहाँ पर वाइब्रेशन क्रिएट किया गया. सो एज यू हैड क्रिएटेड द वाइब्रेशन ऑन दिस वन मींस यू हैड सप्लाइड एनर्जी टू इट, दैट इज द मैकेनिकल एनर्जी. And due to this mechanical energy, what will happen, this particle will vibrate and it will come closer to particle B. तो A जो होगा वो वाइब्रेट करते हुए B पार्टिकल के पास आएगा. And when it is coming over there, it carries the energy and then transmit it to B by interacting with it. So when it is coming towards B or came very close to B, that caused the compression. And after hitting to B, it returns back to its previous condition. And there we can see for the rarer fraction. So when the particles been vibrating and moving towards another particle, which is called to be as compression, and then returns back to its previous condition, is called to be as compression and rarer fraction. After this phenomena, we will observe this, the particle B gets excited, and because of that, it starts vibrating and reaches to C. So now here the compression will take place, and then again it will return back. So it will cause a rarer fraction. And this phenomena will be carried on and on, or it will continue from C to D and so on and on. And that's the thing with where what we have to understand for the propagation of sound, that the energy can be transmitted from one particle to another, and another to another, and another to another, and like that the energy carries on from one end to another end. And this is the propagation of sound, or this makes the sound to travel from one corner to another corner. So over here we are observing compression, and over here you can see that it is rarer fraction. So the movement of the particle is causing the compression and rarer fraction. So this is the concept which we need to understand for understanding the propagation of sound. Now, when we study about sound, then we need to go for the sound waves. So we will see about the waves later on in this class only. While we go for that one, we have to understand some of the very basic terms related to wave. So these are also not new for you all. You had studied about these things. So wavelength. What is wavelength? Wavelength is the length between one crust and trough. So you all know for this thing that this is a baseline, and on this one, if we are having this wave, then the upper column used to be said to be as the crust, and the lower column used to be said to be as the trough. So the distance between the crust and trough, or one complete crust and trough, is called to be as the wavelength. And this is from here to here, and you can represent this wavelength with the Greek letter lambda. Okay. And when you need to measure the length of this wavelength, then you have to express that in the SI unit as meter. On the other hand, when we see for the wave, then we have to come across for the amplitude also. So what is the amplitude? Amplitude is the maximum displacement of the wave from its mean position. So over here, when we see that the crust and trough has been formed, then what is the maximum displacement of the layer of the head of the crust or the head of the trough from the mean position is called the amplitude. Next is the time period. So what is the time period? So time period is the time taken by the wave to form its one oscillation. Okay, so the time it takes to form its complete one oscillation is called to be as the time period. Next is the frequency. So what is frequency? Frequency is the total number of complete oscillations, or total number of complete crust and trough formed in a time period of 1 second. So 1 second में total जितने crust and trough का एक pair construct हो सकता है, या टोटल कंप्लीट वेवलेंथ्स फॉर्म होते हैं, उसको हम लोग फ्रीक्वेंसी से रिप्रेजेंट करते हैं, या फ्रीक्वेंसी उसे कहते हैं. एंड द यूनिट ऑफ फ्रीक्वेंसी इज हर्ट्ज. बेसिकली वी गो फॉर इट एज इन हर्ट्ज. Next is the velocity of sound. So velocity of the sound, when the sound is traveling from a source. Suppose, for example, this is the source of the sound from where it is producing. So it travels to a distance, and when it is traveling a distance, then there must be a speed of that distance traveling, and that is called to be considered to be as a velocity, because we compare or we consider that sound is traveling in a straight path. So for each particle which is carrying the sound from one to another, that goes in a straight path, or that has a straight direction or a particular direction, hence we consider that one as a velocity. So these are the terms again which I said earlier that you had studied in your previous classes, so you don't have to go through these things in much detail. You know for that. So just a little recap was there. Now let's understand about the waves. So over here we are going to discuss about the types of waves which we are going to see. So we will see for this one as basically when we define the waves, then we can see that there are three different kinds of waves. So the first one is the mechanical wave, the second one is the seismic wave, and the third one is the electromagnetic wave. तो जो वेव होती हैं, वेव्स असल में कई सारे तरह से हम लोग उसको डिफाइन कर सकते हैं या देख सकते हैं, डिपेंडिंग ऑन कि किस तरह के एक सिचुएशन को वो रिप्रेजेंट कर रही है या किस सिचुएशन के लिए वो बनाया जा रहा है, उसके बेसिस पर उसको हम लोग क्लासिफाई कर सकते हैं। तो हम लोगों को जो फिजिक्स में अभी पढ़ने के लिए है वो है मैकेनिकल वेव और फिर इलेक्ट्रोमैग्नेटिक वेव। तो इलेक्ट्रोमैग्नेटिक वेव्स के बारे में हम लोगों ने पहले भी पढ़ा हुआ है व्हेन वी वर डिस्कसिंग अबाउट द स्पेक्ट्रम। तो स्पेक्ट्रम के बारे में जब हम लोग डिस्कस कर रहे थे तो वहां पर हम लोगों ने देखा था इलेक्ट्रोमैग्नेटिक वेव्स, जहां पर कि इलेक्ट्रिकल फील्ड और मैग्नेटिक फील्ड दोनों ही होती हैं, इसलिए एक वेरिएबल कंडीशन क्रिएट होता है विद एक्स एक्सिस, वाई एक्सिस एंड जेड एक्सिस। तो उन तीनों के साथ हम लोगों ने इलेक्ट्रोमैग्नेटिक वेव्स के अलग अलग कॉलम्स, जहां पर कि रेडियो वेव्स, माइक्रोवेव, इंफ्रावेव एंड अदर कॉलम्स जो लाइट से रिलेटेड थी या एनर्जी से रिलेटेड, फोटोन पार्टिकल से रिलेटेड बोल सकते हो, इन सब चीजों को हम लोगों ने डिस्कस किया हुआ था। सिस्मिक वेव के बारे में हम लोगों ने पढ़ा है ज्योग्राफी में। ज्योग्राफी में तुम लोगों ने जरूर इसके बारे में पढ़ा होगा, जैसे ड्यूरिंग द पीरियड ऑफ अर्थक्वेक या वोल्केनिक इरप्शन, इस दौरान सिस्मिक वेव हम लोग देख सकते हैं लैंड स्ट्रक्चर के ऊपर। और हम लोगों को जो इस चैप्टर में डिस्कस करना है वो है मैकेनिकल वेव। मैकेनिकल वेव जैसे कि नाम से ही पता चल रहा है, यहाँ पर एनर्जी को ट्रांसमिट करने के बारे में बात कर रहे हैं हम लोग। यहाँ पर जो एनर्जी ट्रांसमिट हो रही है वो काइनेटिक और पोटेंशियल एनर्जी को कैरी करते हुए दिखा सकता है, इसीलिए यहाँ पर ये मैकेनिकल वेव को हम लोग एक्सप्रेस कर रहे हैं। और इसके हम लोग दो क्लासिफिकेशंस करते हैं, एक है लॉन्गिट्यूडनल वेव और एक ट्रांसवर्स वेव। जब हम लोग लॉन्गिट्यूडनल वेव में देखते हैं, सो दैट हैज एन एग्जांपल ऑफ द साउंड एनर्जी, एंड द ट्रांसवर्स वेव तो वहां पर हम लोग देखते हैं एज फॉर द मूवमेंट इन द water. So both the waves are little bit of different from each other. So यहाँ पर अगर हम लोग देखते हैं लॉन्गिट्यूडनल वेव को, अगर हम लोग सीधे सीधे समझना चाहेंगे तो हम लोग यहाँ पे बोल सकते हैं कि एनर्जी ट्रांसमिट होता है एक से दूसरे के बीच में, और वो कैरी होकर ट्रांसमिट होते चली जाती है जहां तक वो कैरी किया जा सकता है। जबकि जब हम लोग ट्रांसवर्स वेव में देखते हैं तो ये अलोंग द बॉडी ही वो ट्रांसमिट होता है। यहां पर ये अलोंग द बॉडी ये ट्रांसमिट नहीं होता है। लॉन्गिट्यूडनल वेव में जब हम लोग देखते हैं तो वो अलोंग द बॉडी वो ट्रांसमिट नहीं होता है, लेकिन ट्रांसवर्स वेव जो होता है वो अलोंग द बॉडी ये ट्रांसमिट होता है। तो ये एक स्पेसिफिक सी बात है जो कि हम लोग समझते हैं एज अ लॉन्गिट्यूडनल वेव एंड द कंडीशन ऑफ द ट्रांसवर्स वेव। तो यहाँ पे देख सकते हो, दो एग्जाम्पल देकर हम लोग इसको देख सकते हैं। एक अगर हम लोग एक रोप ले लें या एक बड़ी सी एक स्ट्रिंग ले लें और उसको किसी एक एंड से अगर हम लोग बांध देते हैं और किसी दूसरे एंड से अगर उसको शेक आउट करते हैं, then we will observe that the whole body is causing its motion over here. So over here this condition is showing that the whole body is getting the energy and it has been transmitting throughout the body from one end to another end. But on the other hand, when we see for this kind of situation, then we can observe this thing that the energy has been transmitted from one to another, and it been carried from this end to this end, and this carrying of the energy is making the wave to be formed over here with the help of the compression and rarer friction. तो जो स्लिगी होती है, स्लिगी में अगर हम लोग उसको स्ट्रेच करते हैं और फिर उसमें अगर हम लोग एनर्जी एंड अप करते हैं तो वहां पे देखते हैं कि किस तरह से ये मूवमेंट हो रही है। इसी दौरान तुम लोगों के कॉर्नर में एक वीडियो भी आ रहा होगा, वहां पे तुम लोग देख सकते हो मूवमेंट ऑफ द पार्टिकल्स। तो उस मूवमेंट ऑफ द पार्टिकल्स को समझो कि जहां पर ऊपर में देख रहे हैं लॉन्गिट्यूडनल वेव, तो लॉन्गिट्यूडनल वेव में तुम लोगों को दिख रही होगी कि पार्टिकल्स जो होते हैं वो एनर्जी किस तरह से ट्रांसमिट कर रहे हैं। तो वहां पे देखोगे कि एक पार्टिकल दूसरे पार्टिकल को एनर्जी ट्रांसफर करके वो फिर से वापस चला गया। तो जब पार्टिकल आगे की तरफ मूव किया, जब रेड पार्टिकल जो है वो आगे की तरफ मूव किया, तो उसने वहां पर एनर्जी कैरी करके दूसरे पार्टिकल्स तक लेकर गए और उसको वहां पर ड्रॉप करके रिटर्न बैक हो गया। तो जब वो उसके पास गया तो वो कंप्रेशन हुआ, और जब वो रिटर्न बैक हुआ तो रेयर फ्रैक्शन हुआ। इसलिए तुम लोग देख पा रहे होगे कि वहां पर कॉलम में एक एक पोर्शन में डार्कर एंड्स आ रही है। वो जो डार्कर एंड्स आ रही हैं वो है कंप्रेशन, और जो लाइटर एंड्स आ रही हैं वो वहां पर दिखा रहा है रेयर फ्रैक्शन। एंड दिस इज द कंडीशन व्हिच हैपेंस in the movement of sound in any kind of medium, whether it is solid, liquid, or gas. Whereas in the lower part of the video, you can see over there that how the transverse waves are going. वहां पे देखोगे कि पूरी की पूरी वेव ही आगे की तरफ मूव कर रही है, जैसा कि हम लोग ऑब्जर्व करते हैं। मान लो कि पानी का कोई कोई वाटर बॉडी है और उसके बीच में तुमने कोई पत्थर फेंका, तो जैसे ही तुम पत्थर को फेंकते हो तो वहां पर वेव क्रिएट होती है, और वो वेव जो है वो उस पॉइंट से लेकर अपने एंड पॉइंट तक ट्रैवल करती है, और वहां पर पूरा का पूरा पार्टिकल ही ट्रैवल कर जाता है। तो ये बेसिक से डिफरेंस है जो लॉन्गिट्यूडनल वेव और ट्रांसवर्स वेव को एक दूसरे से डिफरेंशिएट करता है। So this one was the thing which we need to understand for the condition of the mechanical waves. Now over here we are going to discuss about the difference between the sound and the light, because when we were discussing about light, we had understood that light is also a form of energy. It travels in the form of wave, even though it shows a property of particle as well as it shows the particle of wave. So we will study about the light as under the particle theory, as well as we will study about it under the wave theory. So over here you can understand that when we come for the light, then we comparatively say like this thing, that the light waves used to travel in the form of the transverse wave, whereas the sound is traveling in the form of a longitudinal wave. As transverse wave, when we say for the light, then under that one we know for this thing that light can travel without any particular medium, so it doesn't require any medium over there, because the particles are only been traveling from one end to another end. But when we come for the sound energy, or the sound, then we know for this thing that it requires a material medium, because over here we have to understand this thing, that the particle is not traveling the throughout distance. It is transmitting the energy from one end to another end, and when it is making the particles to move from one particle to another particle, or when it is allowing the energy to be transmitted from one particle to another particle, then there must be more than one particle should be present, or there must be more than one particles. And if that will be there, then only we will understand this, that the energy can be transmitted with the help of number of particles, and when number of particles are present over there, then there must be a matter. So that is the thing which we need to remember. Next of all, the thing is that when we come for the light, then its speed is enormously high. So it is very fast. So when we come for the speed of the light in vacuum, it is around to be 3 lakh meter per second. So even though if we are not taking it for vacuum, even we can go for the condition of air, where we can compare the speed with the light, then we know for this thing that the speed of light is around to be 2.8 into 10 to the power 8 meter per second. So this is also very fast. Whereas when we go for the sound, then we know it is around 330 meter per second. So this is a huge difference between both the columns. So these are the basic things which we need to understand for the differentiation of the sound wave and the light wave. Now let's understand the next topic which we have to see over here, that is the reflection of sound. So again, students, in class 10th, we are not going to discuss a lot about the reflection of sound, because again, this we had studied in our junior classes. So here we are just taking a little recap of those things. So the reflection of sound is the same like we go for light. So when the light rays hit any opaque body, it used to reflect back in the same medium. In the same way, when we observe the sound is hitting to a rigid body or a very hard body, and it is not able to transmit it, or it is not able to make the vibration in that body, or that body is not going to absorb a lot of amount of energy, then what happens? The sound waves gets returned back, and this returning back of the sound is said to be as the reflection of sound. So when the sound is returning back by after hitting any rigid body or a very hard body, and then that is called to be as the reflection of sound. Now over, when we understand about the reflection of sound, then we have to understand that it also follows the same principle or the same law of reflection as what we had studied under the reflection of light. So over here also, the incident ray, the reflected ray, and the normal used to lie on the same plane. And over here also, if you will construct the angle of incidence and the angle of reflection, that is also going to be the same thing. You can understand the condition of reflection of light, the reflection of sound when you are in an empty room. Okay, so over there you can understand about that one. So when you are alone in a room, or when you are present in an empty room, then you can understand the reflection by hearing the reverberation. Okay, so when the sound is continuously reflecting again and again, and the sound has been heard in a little different manner, it has been heard in a little louder than to the regular condition, then that is called to be as the reverberation. Is when it is vibrating again and again by hitting to different bodies which is present over there, mainly the wall or the things which is present over there. So that is the reverberation. So reverberation is a very common phenomena which we can observe. So you may know for this thing that many people are very good bathroom singers. So why it is like that? It is because when you are over there, then the sound is reverberating continuously. So you feel that the sound is going to be very loud, or it is very interesting to listen. And because of that only, the people used to sing along there, even though that sound is not going to be very relaxing, or most people will not like that kind of sound, but it is present over there. So reverberation is a condition where we used to observe that the sound can reflect numerous times in a particular room, or at a particular place in a different manner or in a continuous manner. Now, students, you need to remember one more thing over here, that reverberation is different from echo. So echo is also is due to the reflection of sound. Echo और reverberation दोनों ही अलग अलग टर्म है. Even though जब हम लोग echo के बारे में पढ़ते हैं तो वो reverberation से बिल्कुल अलग चीज है. दोनों ही रिफ्लेक्शन ऑफ साउंड से ही तैयार होकर आती है, लेकिन यहाँ पर हम लोग एक डिफरेंस देख सकते हैं. डिफरेंस में क्या 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 हम लोग देखने वाले हैं. जब रिवर्बरेशन बोलते हैं तो इसका मतलब हो रहा है कि जो साउंड है वो कंटिन्यूअसली रिफ्लेक्ट कर रही है, उसके कारण एक 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 लाउडर फॉर्मेट ऑफ साउंड जो है वो, या गूंजता हुआ साउंड जो है वो तुमको वहां पे सुनने को मिल सकता है. लेकिन जब इको के बारे में बात करते हैं तो इको दोहराना होता है. साउंड जब दोबारा या तिवारा तुम लोग सुन पा रहे हो आफ्टर द ओरिजिनल साउंड, मींस व्हेन यू कैन हियर द ओरिजिनल साउंड एज वेल एज द रिफ्लेक्टेड साउंड वेरी क्लियरली for the first time or for the second time continuously, or twice or thrice again and again, then that is called to be as an echo. So these are the things which you need to remember. So when we come across for the situation of an echo, when we see for the echo, then we understand this thing, that echo is a condition or a situation where we can hear the sound again after it reflects back from the origin, and can be heard once again after the original sound has been heard. ठीक है, तो एक बार ओरिजिनल साउंड सुन लेने के बाद अगर फिर से दोबारा अगर वो साउंड सुनने को मिलता है, तब वो हो जाता है वहां पर इको. तो ये इको का फिनोमिना जो है, इको का फिनोमिना के लिए हम लोगों को कुछ बेसिक सी कंडीशन की रिक्वायरमेंट होती है. तो इसमें हम लोग क्या देखते हैं, जो हम लोग स्पीड ऑफ द साउंड लेते हैं. अच्छा, इसमें इसमें एक बेसिक सा कैलकुलेशन कर लेते हैं. सपोज फॉर एग्जांपल, दिस इज द सोर्स ऑफ साउंड, this is the source of sound, and this is the reflecting body. This is the reflecting body. Now sound will travel over here, it will travel over here, and then again it is going to return back, and then that is called to be as an echo, when you can hear the same sound again after you had heard the first original sound. So over here you can see this thing, that we don't know how the distance, we don't know the distance, what is the distance is required to have the minimum echo. So say as for example the distance is x, so x is going and x is coming, so total distance will be as 2x. Now the speed of the sound, which is normal in the atmosphere, that is said to be as 330 meter per second. And one more thing which we have to understand to clarify the echo, that is our own hearing capability. So when we are listening in sound, then our ears respond on that, and it sends a signal to our brain, and brain used to identify that sound, and we do respond on that. So it takes a time period, and that time period is 1/10th of the second. So when we speak out, whenever we produce any sound, then instantly we can hear the first sound which has been produced over there. After that, the second sound can be only heard if the second sound has a gap of 1/10th of the second. So over there, if we need to hear the second sound, means if we need to hear the echo over there, then the time period should be at least 1/10th of the second. Now, when we do the calculation over here, simple distance is equals to speed into time. So over here, we can see 330 into 1/10. So this will be cancelled over here, and this is 2x. So therefore, the value of x is going to be 33/2, and when you cancel it, it is going to be 16.5. So if we take it as a round up value, then 17 meters. The minimum distance is that is 17 meters, which is required for the condition of an echo to form. So if you are listening the sound once again when you speak out in a huge empty hall, or you are standing in front of valley, and over there when you produce the sound and you can hear the sound once again after the original sound, then what happens? It is called to be as an echo. So it is little different from the reverberation. Okay. Now we know there are several uses of echo. One of the very basic use of the echo is the sonar system, the sound and navigation ranging system. So that is a very common instrument which we use under the seabed, or over the different instruments or different industries to do different kinds of activities. So echo, or the reflection of sound, is a useful phenomena or useful thing to perform different kinds of activities, not only in our basic world, but also in the medical field. Also we use ultrasonic sounds, or ultrasonic sonic imaging system, and with that one we can identify any kind of irregularities or any kind of problems which is going on inside our bodies. So the echo or the reflection of the sound, both are very important. So it is not like that always the reflected sound is the echo, but yes, echo is a reflected sound. So we use this reflection of sound at many places in many different perspectives, and they are very useful at different ways. Now, when we are discussing about this, then as we had already understood about the reverberation, so we had cleared out all these things. So I hope you all are getting all these things which is present over here. So echo and reverberation is done. Now we are coming to the main topic of this chapter, that is the types of vibration. So this is a new concept for you all, because the previous components which we were discussing, that we had already understood in our previous classes. So over here, we are going to discuss the types of vibrations. What is the type of vibration? What are the different types of vibration? The very first one, we are starting with the free vibration. यहाँ पे हम लोग सबसे पहला जो डिस्कस करने वाले हैं वो है free vibration. Free vibration होता क्या चीज है? So in a simple way, we can say that the periodic vibrations of a body which used to occur with a certain amplitude in the absence of any external force is called to be as the free vibration. So किसी भी बॉडी को जब हम लोग हिट करते हैं तो वो वाइब्रेट करता है, ठीक है। एक सिंपल सी कॉन्सेप्ट है, अगर हम लोग किसी भी बॉडी को हिट करते हैं तो वो वाइब्रेट करता है, ठीक है। अगर तुम इसको कस के हिट करोगे तो ये कस के वाइब्रेट करेगा, अगर तुम इसको धीरे से हिट करोगे तो वो धीरे से वाइब्रेट करेगा। लेकिन दोनों ही सिचुएशन में एक ऐसा कंडीशन हमको देखने को मिलता है जहां पर कि वो इंडिपेंडेंटली वाइब्रेट नहीं कर पा रहा है। क्योंकि जैसे कि सपोज मान लो कि एक बॉडी है, रिजिड बॉडी ही लेते हैं यहाँ पर, और इसमें एक सर्टेन इलास्टिसिटी है, ठीक है, एक इलास्टिसिटी है, और इस इलास्टिसिटी के साथ ये वाइब्रेट करने वाला है। तो जब हम लोग इसके ऊपर फोर्स अप्लाई करेंगे, जब हम लोग इसके ऊपर फोर्स अप्लाई करते हैं तो ये यहाँ पे वाइब्रेट करता है। तो अब जब ये वाइब्रेट किया तो एक्सटर्नल फैक्टर्स यहां पर रहते हैं, जैसे कि फॉर एग्जांपल द इंटरनल फ्रिक्शन ऑफ द पार्टिकल्स, the air pressure which is present outside, the elasticity of the body, all these factors are responsible over there. So इन सभी factors को छोड़कर अगर ये factors नहीं होते वहां पर और उसके हिसाब से अगर वो वाइब्रेट करता, then that would be called to be as the free vibration, where the vibration is not under any external effect or any external factors. So that is a free from all the external condition, that is called to be as a free vibration. So normally if we are hitting a body, then we can say that it is coming closer to the free vibration, but it is not that. It has been reached to the free vibration. Now whenever we are talking about the free vibration, then we used to observe that due to the external factor there is another condition which occurs, that is called the damped vibration. अभी अभी जैसा कि हम बताएं कि कोई एक रिजिड बॉडी है और तुमने उसे हिट किया, उसमें तुमने फोर्स लगाया और फोर्स लगाकर तुमने उसे हिट किया, तो जैसे ही वो तुम हिट करते हो इट विल वाइब्रेट। और जैसा कि अभी बताया एक्सटर्नल फैक्टर्स वहां पे मौजूद है। एक्सटर्नल फैक्टर्स का मतलब हो गया जैसे कि बता रहे थे कि इंटरनल पार्टिकल्स की जो फ्रिक्शन है वो एक्सटर्नल एयर और एक्सटर्नल अलग अलग जो प्रेशर्स हैं उनके उनके इफेक्ट्स वहां पर क्या हो रहे हैं। इसके कारण होगा क्या, जो एनर्जी इसमें ट्रांसफर किया गया है वो एनर्जी धीरे धीरे करके कम होती चली जाएगी, because some of the energy is getting waste out, or the some of the energy is working to overcome the external effects. जो external effects हैं उसको overcome करने में वो खत्म हो रही है, जिसके कारण जो एनर्जी का ट्रांसमिशन होने वाला है आगे की तरफ वो वहां पर कम होते चले जा रहा है, जिसके कारण एम्पलीट्यूड जो है वो स्लोली स्लोली हर एक कंप्लीट ऑक्सिलेशन के बाद कम होती चली जाती है और वो खत्म होती चली जाती है. So this is called the damped vibration. Okay, so you can understand this one with a simple example. If you take a pendulum, okay, suppose there is a pendulum over here and this is there. So this is the pendulum. So if you will lift it to a height, if you are lifting it to a height and then you drop it, so you will observe that slowly after each oscillation it is coming slower, getting slower, and one time it would be there that it comes to rest. Why it is so? It is because of the external resistance, that is the air resistance which is acting over there. In the same way, whenever we are vibrating any body, जब भी हम लोग किसी body को vibrate करते हैं, then external factors क्या करते हैं, उसके energy को consume करते चले जाते हैं, and as its energy gets consumed, what happens? It causes the damped vibration. Okay, now let's move to the next one, that is the forced vibration. So what is forced vibration? So if we don't want that pendulum to reduce down its rate of oscillation, then what we need to do? We need to continuously put a force over there. So suppose, for example, you are sitting on a swing and the same situation occurs like a pendulum. So you had moved for once, and after that you were getting slower, so that was the damped vibration. But if you had asked your friend to continuously cause a push in the forward direction, then what would happen? The amount of energy which you are losing due to the external resistance or the air resistance, you will gain it from the push which your friend is causing over there. And due to that, what happens? You are continuously maintaining your motion and you will continuously move with the same amplitude, and that is the forced vibration. तो simple तरीके से अगर हम लोग समझते हैं तो हम लोग यहाँ पे देख सकते हैं कि जो पेंडुलम है, जैसे कि पेंडुलम है, पेंडुलम के जैसा ही स्विंग का भी एग्जांपल ले सकते हैं। तो अगर पेंडुलम है तो पेंडुलम को अगर तुम एक तरफ लिफ्ट करते हो तो और उसके बाद उसको तुम छोड़ देते हो, then you will observe that it is continuously moving, वो वहां पर continuously move कर रहा है, लेकिन हर एक ऑक्सिलेशन के बाद उसकी स्पीड थोड़ी थोड़ी कम होती चली जा रही है क्योंकि एयर रेजिस्टेंस वहां पे मौजूद है। लेकिन अगर इसके हर एक ऑक्सिलेशन के बाद तुम अगर उसमें थोड़ा सा एनर्जी और डाल दो, उतना ही एनर्जी जितना वो लूज आउट कर रहा है, then what will happen? It will maintain its motion like that. So when it is like that, or when that body is continuing with the same motion with that extra amount of force, that is called to be the forced vibration. Means we are maintaining the vibration with the same rate of oscillation by providing some extra force on the body. Okay, so this was the forced vibration. Now we are coming to the resonance. So what is now resonance? So resonance is the result of the forced vibration. रेजोनेंस जो है वो एक सिचुएशन है जो कि हम लोग फोर्स्ड वाइब्रेशन के लिए देखते हैं। तो अभी अभी फोर्स्ड वाइब्रेशन में बताया कि कोई बॉडी अगर वाइब्रेट कर रहा है तो वो धीरे धीरे अपने एक्सटर्नल रेसिस्टेंस के कारण वो अपना एनर्जी खोता रहता है। और उसको अगर हम चाहते हैं कि वो उसी एनर्जी के साथ बना हुआ रहे, वो उसी रेट ऑफ मोशन के साथ चलता रहे, तो हमको क्या करना पड़ेगा? एक्सटर्नल फोर्स डालना है, जिसको कि हम लोग फोर्स्ड वाइब्रेशन के रूप में समझते हैं। तो जब हम लोग फोर्स्ड वाइब्रेशन के साथ किसी बॉडी को एक सर्टेन पीरियड तक चलाते चले जाते हैं, देन इट रीचेस टू इट्स नेचुरल वाइब्रेशन। So when the body reaches to its natural vibration or it meets to its natural frequency, then the body is considered to be as a resonance. यानी जब हम लोग किसी बॉडी को वाइब्रेट करते हैं, कोई एक पर्टिकुलर बॉडी है उसको हम लोग वाइब्रेट कर रहे हैं और वो वाइब्रेट करके वो अपना एनर्जी लूज आउट कर रहा है, लेकिन हम उसको कंटिन्यू बना कर रखने के लिए इसमें कंटिन्यूअसली एक्सटर्नल फोर्स पुटअप करते चले जा रहे हैं। जब उसके ऊपर एक्सटर्नल फोर्स पुटअप करते चले जा रहे हैं, तब वो क्या रहा है? ये अपना एनर्जी लूज आउट नहीं कर पा रहा है, तो कंटिन्यूअसली ये वाइब्रेट करती चली जाती है। ये वाइब्रेट करते 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 एक टाइम ऐसा आता है कि ये अपने खुद के नेचुरल वाइब्रेशन के साथ मीट कर जाता है। और जैसे ही इसका नेचुरल वाइब्रेशन के साथ इसका मीटिंग पॉइंट आ जाती है, देन दिस यूज्ड टू स्टार्ट वाइब्रेट वैग्रसली एंड दैट इज द सिचुएशन ऑफ द रेजोनेंस। तब वहां पर वो हम लोग रेजोनेंस देख सकते हैं। तो जैसे कि फॉर एग्जांपल स्विंग के साथ है, तो फोर्स्ड वाइब्रेशन अगर कंटिन्यूअसली उसमें देते चले जाएंगे, तो एक टाइम ऐसा आएगा जहां पर कि तुम लोग ऑब्जर्व कर सकते हो कि ये स्विंग जो है, ये स्विंग काफी ज्यादा स्पीड को गेन कर जाएगा, बिकॉज व्हाट विल हैपन ओवर देयर, दैट द स्विंग विल रीच टू इट्स नेचुरल फ्रीक्वेंसी और इट्स नेचुरल वाइब्रेशन, एंड बिकॉज ऑफ दैट इट विल स्विंग फॉरवर्ड एंड बैकवर्ड continuously in a very vigorous pattern or in a very vigorous condition, and that is called the resonance. So resonance is actually a condition or in a body where it meets to its natural frequency or where it reaches to its natural vibration due to the forced vibration. जब हम लोग continuously forced vibration किसी बॉडी में डालते हैं और वो अपने नेचुरल वाइब्रेशन के साथ मीट अप कर जाता है, तो उस कंडीशन में हम लोग वहां पर रेजोनेंस को देख सकते हैं। तो रेजोनेंस के कई सारे अलग अलग एग्जांपल्स हम लोग देख सकते हैं, लेकिन जो एक बेस्ट एग्जांपल के फॉर्मेट में हम लोग देखा जा सकता है वो है द वर्किंग ऑफ अ रेडियो और द वर्किंग ऑफ द कंडीशन ऑफ अ sound box, or one more thing you can say for that, the working of the television which you used to see due to the dish TV or this antenna. So how do they used to do, how do that used to work over there? So see what happens in a radio. So you may used a radio, so there is an antenna, okay, and this antenna is actually to receive the frequency which has been transmitted by the radio stations. So रेडियो स्टेशंस अलग अलग फ्रीक्वेंसी पर वो इन्फॉर्म वो वेव्स छोड़ती हैं या फिर वहां वाइब्रेशन काउज होती हैं, और ये जो वेव्स यहाँ पर एयर में ट्रांसमिट हो रही हैं, ये एंटीना इसको कैचअप करती है, और एंटीना इसको कैचअप करके रेडियो को हेल्प करती है ट्यून इन करने के लिए विथ दिस वाइब्रेशन। And as soon as the radio gets collaborated with this wave, what happens? The radio starts speaking out, or this radio starts gives the sound what this wave is transmitting over there. So that is the concept of the radio. Okay, so radio is not something. If you had seen radios, then you may know for this thing that radios work on a particular frequency or a band, say as for example 107 hertz. So this is a value on which the radio is going to resonate. In the same way, the dish antenna at your home, which is present over there at the rooftop, it used to match it, or it used to hold, or it used to get collaborated with the waves which is coming in from the source, or whatever the source is sending, they are receiving it, and with that one it collaborates, or it used to combine in such a situation that the setup box which is present over there, it starts doing vibration, and this vibration is a technical vibration or electrical vibration which happens inside, and with that one it used to transmit the information in the TV. One example you can see understand with this tuning fork also, that how the resonance is working. So over here you can see that one wooden box is there, which has been surmounted with a tuning fork of a certain frequency. The another wooden box of the same size has been also surmounted with one more tuning fork of the same frequency. Okay. Now what you do, you just hit a rubber band or a rubber ball to this first tuning fork. Name it as, say as for example, this one is box A and this one is box B. So this tuning fork is A, and then this tuning fork got vibrated. And as this tuning fork A gets vibration, what happens? It causes a vibration inside this wooden box or the sound box, and the air which gets vibrated over there, it used to transmit in the forward direction because they got excited and they have the mechanical energy. And when this air is reaching inside the B component or the B sound box, then it starts making the air to vibrate over here also. And as the air of the B box vibrates and reaches to its natural frequency, you will observe the tuning fork which was over here, it will start vibrating with the same frequency as to the first one, even though you haven't touched this, even though no any kind of motion has been caused externally by us on this tuning fork. So why this happened? This happened because of the resonance. The wave which has been transmitted from this first sound box reached to the second sound box, and it had created the resonance, and due to that this box is vibrating, or this tuning fork is vibrating. So this is the impact of resonance. So there are so many different examples of resonance. So right now in this on the other side you can see a video where you can see that how due to the resonance only the bridge is shaking and the whole motion is going on. So this is the impact of resonance, which is due to the air which is striking to the bridge. It had created such kind of vibration that it need to its natural vibration, and then it is now vibrating with a enormous energy. That is the resonance over here. So till here, this was the thing which we need to discuss. Now we are coming to the part 2 of the book, where we are going to discuss about the characteristics of the sound. So when we discuss about the sound, we know for this thing that sound travels in in a form of a longitudinal wave, where it requires a material medium. So whether it is a solid, liquid, or gas, and when it travels over there, then the density of the material, elasticity of the material determines the speed of the sound. So these are the basic characters which we had already studied in our previous classes. But the main characters which we are going to discuss over here, that is related to the loudness and the pitch and the quality of the sound, which is depending on the frequency, amplitude, and the tone of the sound. So all these things we will slowly understand over here also. Again, so loudness is one of the character. Then we will see for the pitch, and then we will see for the quality of sound. So when we come for the loudness, simply we can say loudness and pitch both are considered to be as the main character of the sound, and the quality of sound is totally different, or can be said to be as a different than to the loudness and the pitch. Because of the same loudness with the same pitch, the quality of the sound can be different. So what is that, and what are the factors on which this used to depend? Let's see and understand. But before we go for those characters of sound, here are the components which you need to understand for classifying the characters of sound. So I hope you remember, as we had discussed earlier in this class only, what is frequency, what is time period, what is amplitude, what is wave, and the oscillation. Oscillation is actually the movement of the particle when the particle is carrying the energy from one end to another end and then again returns back. That is one oscillation, and due to that one oscillation we create the wave. ओके सो जब हम लोग वेव बनाते हैं, असल में वो वन ऑक्सीलेशन को दिखा रहा होता है। जैसे कि फॉर एग्जांपल हम पहले तुम लोग को बता चुके हैं कि जब हम लोग किसी भी बॉडी में हिट करते हैं तो एनर्जी ट्रांसफर होती है एक पार्टिकल से दूसरे पार्टिकल। तो सपोज दिस इज ए पार्टिकल एंड दिस इज बी पार्टिकल। तो अगर हम लोग एनर्जी ट्रांसफर किए हैं ए पार्टिकल में, तो यहाँ पर होता क्या है कि ये ए पार्टिकल वाला एनर्जी जो है ये ट्रांसमिट करेगा अपना एनर्जी टू बी पार्टिकल बाय कमिंग क्लोजर टू इट। तो ये इसके पास आया, पास आने के बाद फिर वो दूर जाता है, तो ये वन ऑक्सीलेशन हुआ। तो पास आना, एनर्जी को ट्रांसमिट करना और दूर जाना, ये होता है यहाँ पर वेव को दिखाना। तो इसको हम लोग कैसे दिखाते हैं? तो ये हम लोग दिखा सकते हैं कि जब पार्टिकल को एनर्जी मिला, ए पार्टिकल को एनर्जी मिला, देन इट गेट्स हायर, ओके, एंड आफ्टर दैट इट रीचेस टू द सेकंड पार्टिकल, वो पार्टिकल बी तक पहुंचता है, उसको एनर्जी ट्रांसफर कर दिया। नाउ बी पार्टिकल इज एनर्जेटिक and A is returning to its previous situation, so that is compression. So this the trough which is forming, it is the rarer fraction, and the crust which is forming, that is the compression. So when the particle is coming closer to the second particle, then that is compression, and when it is returning back, then that is known to be as the rarer fraction. So these are the things which you need to remember while we understand about the characters of sound. Now let's see for the loudness of the sound. So how we can classify this loudness of the sound? So to classify this one, and we can say this thing, that it is a property by virtue of which the loudest sound can be distinguished from a faint sound. So if you are going through two different sounds, अगर तुमको दो अलग अलग sound सुनने को मिलते हैं और उसमें से तुम लोगों को डिस्टिंग्विश करना है एक साउंड को एज अ लाउडर और दूसरे साउंड को उसमें से कम या उसमें से कमजोर साउंड तुमको आइडेंटिफाई करना है। तो उस कंडीशन में हम लोग उसको देख सकते हैं या उसको हम लोग आइडेंटिफाई कर सकते हैं एक पर्टिकुलर प्रॉपर्टी के साथ, और उसी चीज को हम लोग कहते हैं लाउडनेस। एंड दिस इज डिपेंडिंग फ्रॉम पर्सन टू पर्सन, ये अलग अलग लोगों पे अलग अलग हो सकता है। किसी किसी को कोई साउंड लाउडर लग सकती है, किसी को कोई साउंड नहीं लग सकता है। लेकिन अगर न्यूमेरिकल वैल्यू में देखते हैं, अगर हम लोग न्यूमेरिकल वैल्यू में कैलकुलेट करके देखते हैं, तो डेसिबल एक यूनिट है जिसके बेसिस पर हम लोग उसको कैलकुलेट करके ला सकते हैं और उसके हिसाब से हम लोग लाउडनेस को डिटरमाइन भी कर सकते हैं। तो जब कोई साउंड प्रोड्यूस होता है, जैसे सपोज मान लो कि दो अलग अलग साउंड प्रोड्यूस हुए हैं विद द सेम पिच एंड द सेम फ्रीक्वेंसी, सो वन साउंड कैन बी ऑफ अ हाई और can be said to be as a very loud, and one can be heard to be as a very faint. But again, you need to remember this thing, that this is a character primarily which is depending on the person who is listening to that. So someone can be identifying any sound a very loud sound, and some other one can identify the same sound as a faint one or not so very loud. Okay, but when we come for the scientific study, then we know for this thing that there are some various factors on which this loudness used to depend. So the amplitude of the sound, the distance from the source, area of the vibrating body, the density of the medium, and the presence of the resonant body. So all these are the factors on which the loudness of the sound used to depend. So let's understand how they are depending and what are the factors which we need to remember over here. सो जब हम लोग लाउडनेस को डिफाइन करते हैं या उसको हम लोग कैरेक्टराइज करके उसके बारे में हम लोग स्टडी करते हैं, तो हम लोग ये ऑब्जर्व करते हैं कि लाउडनेस जो है वो कई सारे अलग अलग फैक्टर्स के ऊपर डिपेंड करता है। जो सबसे पहला फैक्टर हम लोग यहाँ पे देखने वाले हैं, लाउडनेस इज डायरेक्टली प्रोपोर्शनल टू द स्क्वायर ऑफ द एम्पलीट्यूड। तो जब कोई वेव क्रिएट होती है, जब कोई वेव का फॉर्मेशन होता है, तो उसका एक सर्टेन एम्पलीट्यूड होता है, और इस एम्पलीट्यूड के साथ जो लाउडनेस है वो डायरेक्टली प्रोपोर्शनल होता है उसके स्क्वायर के साथ। तो यहाँ पर हम लोग देखते हैं लाउडनेस इज डायरेक्टली प्रोपोर्शनल टू द स्क्वायर ऑफ द एम्पलीट्यूड ऑफ द साउंड। सो यू कैन टेक वन, दिस इज एज इक्वेशन 1। सो एम्पलीट्यूड जितना बढ़ेगा उसके हिसाब से मेरा लाउडनेस भी इंक्रीज होगा, एम्पलीट्यूड जितना कम होगा लाउडनेस भी उतना ही कम होगा। Next factor which we need to remember over here, that is the loudness is inversely proportional to the square of the distance between the body, means the receiver, as well as the source. So suppose for example there is a speaker over here and you are standing very close to that speaker. So the sound which is coming out from that one, you may hear that sound very loud, or you can recognize that sound very loud. So if you are hearing the same sound with a distance, then you will hear the same sound with the same amplitude, with the same frequency, and all the things, you will find that it is not so very loud. So thus if we say that it is inversely proportional. So as closer you will be there, what will happen? The loudness will be more, and as far you will be, the loudness will be less down over there. The next thing which is there, that is the surface area. So over here we know for this thing that the surface area plays a very important role under the condition of the loudness. तो यानी loudness के लिए surface area भी एक important factor होती है। हम सीधे सीधे डायरेक्टली प्रोपोर्शनल या इनवर्सली प्रोपोर्शनल का कोई रूल नहीं डाल सकते हैं, लेकिन हाँ हम लोग ये समझ सकते हैं, एक सीधे सीधे तरीके से ये बोला जा सकता है कि फॉर अ लार्जर सरफेस एरिया द साउंड विल बी मोर लाउडर। जैसे कि फॉर एग्जांपल जो बड़े बेस ड्रम्स होते हैं, उनको जब हम लोग हिट करते हैं तो उससे उसका जो सरफेस एरिया है वो काफी बड़ा होता है, जिसके कारण वो लाउडर साउंड प्रोड्यूस करता है। दूसरी तरफ जो छोटे ड्रम्स होते हैं या छोटे छोटे मुंह वाले जो जो भी इंस्ट्रूमेंट होंगे कंपेयर टू द बेस ड्रम, दैट वी विल ऑब्जर्व दैट इट प्रोड्यूसेस साउंड बट इट इज नॉट सो वेरी लाउड एज द बेस ड्रम यूज्ड टू डू सो। So that is the thing which we need to understand. The next factor which is there, that is the density of the medium. So more the density of the medium, more the sound will be louder. So when we come for the mediums or the body or the material which is producing the sound, or which causes the vibration to produce the sound, if it has a greater density, then we used to observe that the loudness will be more. तो जितना ज्यादा density होगी उतना ज्यादा ही loudness वहां पर होगा। Next, we know for this thing that the loudness is depending on the resonant body. So as just now we had understood the situation of the two sound boxes, so over there we can understand that how loudness can be impacted by the resonant body. So if a body which is present over there and it is causing a vibration which can make the other body to reach to its natural vibration, then we can observe that the loudness can increase, because this body is already vibrating and it makes another body to vibrate, and that also vibrate to its natural vibration. So the obvious thing is that the rate of vibration will be more and the loudness will be also very much high. So that is the thing which you need to remember over here. Now let's understand the condition of loudness with the perspective of intensity. So intensity is a completely new thing which you are studying over here. When you come across for intensity, जब तुम लोग intensity के बारे में पढ़ते हो तो intensity असल में एक तरह का energy का consumption, एनर्जी कितना कंज्यूम हो रहा है एक पर्टिकुलर पीरियड ऑफ टाइम में विथ रिस्पेक्ट टू द एरिया वेयर इट इज बीन अप्लाइड ओवर देयर, दैट गिव्स अस द इंटेंसिटी। तो जब हम लोग इंटेंसिटी के बारे में बात करते हैं, सिंपल लैंग्वेज में अगर हम लोग इसको डिफाइन करते हैं तो हम लोग बोल सकते हैं इट इज द साउंड एनर्जी पासिंग ईच सेकेंड थ्रू ईच यूनिट ऑफ द एरिया, दैट इज कॉल्ड टू बी एज द साउंड, द इंटेंसिटी ऑफ साउंड। यानी इसको सिंपल तरीके से हम लोग बोल सकते हैं कि कितना साउंड एनर्जी ट्रैवल कर रहा है पर सेकेंड किसी एक गिवन एरिया में, इससे निकल सकती है इंटेंसिटी ऑफ द साउंड। तो जब भी कोई भी एक स्पीकर साउंड प्रोड्यूस करता है तो स्पीकर का डायमीटर जितना बड़ा होगा, उसका डायमीटर जितना बड़ा होगा वो उतने बड़े एरिया में, so say as this is the area, it is allowing the energy to transmit. It is making the energy to travel. It is making the energy to move in the forward direction at every second. So that is the amount of thing which we need to remember. That is the thing which we need to understand over here. So intensity is actually, or it can be defined as the power carried by the sound waves or sound energy at a particular unit area in a given direction. Hence, we come to the unit as watt per meter square, because as you can see over here, this is the basic formula. Intensity is equals to E upon T upon area. So the E upon T, that is the power, and power upon area is the ultimate calculation of the intensity. And there is a huge relation between the intensity of sound to the loudness, because even though they are not dependent, okay, remember for this thing that they both are different from each other, but the intensity used to determine, the intensity help us to calculate the loudness of the sound, because it gives us that how much energy has been emitted in a particular area in a unit time period. So that gives that makes an establishment of calculation where we can understand the sounds loudness can be calculated. तो हम लोग यहाँ पर एक सिंपल से कैलकुलेशन को करके समझ सकते हैं कि लाउडनेस को कैसे कैलकुलेट किया जा सकता है। देखो, जब हम लोग लाउडनेस के बारे में बात करते हैं तो वैसे इंटेंसिटी और लाउडनेस दोनों ही टर्म एक दूसरे से अलग अलग है। जहां पर कि हम लोग लाउडनेस के बारे में जब देखते हैं तो वहां पर एरिया से कोई रिलेशन नहीं है, लेकिन जब हम लोग इंटेंसिटी से देखते हैं तो या इंटेंसिटी के बारे में पढ़ते हैं तो वहां पर एरिया का एक रिलेशन आ जाता है, क्योंकि एरिया के बेसिस पर ही वहां पर कैलकुलेट होती है। तो जब हम लोग लाउडनेस को कैलकुलेट करते हैं, जब हम लोग लाउडनेस को एक्सप्रेस करने के बारे में बात करते हैं, तो वहां पर एक सिंपल सा कैलकुलेशन करते हैं विद द हेल्प ऑफ द लॉगरिथम वैल्यू ऑफ द इंटेंसिटी ऑफ टू डिफरेंट साउंड, एंड बिकॉज एंड व्हाई वी आर टेकिंग इंटेंसिटी, बिकॉज इट इज एक्चुअली द एनर्जी, एंड दैट बिकॉज ऑफ दैट एनर्जी ओनली द साउंड इज ट्रैवलिंग फ्रॉम वन एंड टू अनदर एंड, और फ्रॉम वन पॉइंट टू अनदर पॉइंट। तो इसको हम लोग कैसे कैलकुलेट कर सकते हैं? तो एक सिंपल वैल्यू से इसको कैलकुलेट किया सकता है। सो जस्ट अ मिनट, आई विल डू फॉर दैट एक्सप्लेनेशन ओवर हियर on the white screen. So 1 minute, I will share that page. Now let's understand about the relation between the loudness and the intensity. So when we talk about intensity and loudness, they are not directly related, but they are related in some manner. So when we say for the intensity, it is a calculatable quantity, and when we talk about the loudness, then that is not a calculatable quantity directly, but with the help of intensity we can be able to calculate it out. So जब हम लोग intensity के बारे में बात करते हैं, तो जैसा कि हम लोगों ने पहले डिस्कस किया है कि ये amount of energy consumption in a time period with respect to an area is called to be the intensity. तो जहां पर कि हम लोगों ने intensity का formula already calculate कर लिया है. So intensity is equals to the amount of work done, or the power consumption, we can say the power consumption in a particular area. So over there we know for this thing that we can calculate it out. But when we come for the loudness, then as just now I said that there is no any particular direct rule or formula which is present over there which we can use to calculate the loudness. So how can we do that, or how we can find it out? So actually, when we see for the loudness, we note this thing that it is directly proportional to the square of the amplitude of the sound wave. Hence, whenever the sound is produced, or whenever the sound used to be generated from any kind of source, then we know for this thing that the amplitude determines the intensity. So with that respect, or in that particular context, we can place a relation between the loudness and intensity. So actually there were two scientists, Weber and Fetcher. They had established a relation, and they said that the loudness of the sound can be directly proportional to the log value of intensity. And over there he had said this thing that if we remove this equals to sign, and we can go for it as log is equals to k proportional constant with log I, and this value he had proposed, and with this value only we will be able to calculate, or we can find out the loudness of any body. सी स्टूडेंट देखो, जब हम लोग लाउडनेस को कैलकुलेट करते हैं, जब हम लोग लाउडनेस की को न्यूमेरिकली दिखाने की कोशिश करते हैं, तो वहां पर इंटेंसिटी एक इंपॉर्टेंट क्वांटिटी बनकर आता है, और उसी के बेसिस पर हम लोग अपना कैलकुलेशन कर सकते हैं. तो इंटेंसिटी तो चूंकि एक खुद में ही एक न्यूमेरिकल वैल्यू है, एक फिजिकल क्वांटिटी है जिसकी जिसकी कैलकुलेशन हो सकती है, लेकिन लाउडनेस की कोई कैलकुलेशन सीधे सीधे नहीं हो सकती थी. इसीलिए हम लोग इंटेंसिटी का इस्तेमाल करके या इंटेंसिटी को रिलेट करके इसको कैलकुलेट करते हैं. तो जब हम लोग लाउडनेस के बारे में बात करते हैं, तो उसकी जो यूनिट होती है वो होती है फोन. ठीक है, इसकी यूनिट को हम लोग दिखा सकते हैं फोन, जबकि उसका लेवल ऑफ लाउडनेस को अगर दिखाना है कि हाउ मच इट इज लाउड, और हाउ वी कैन कंपेयर वन साउंड टू अनदर, देन अंडर दैट कंडीशन वी गो फॉर द डेसिबल. Okay, so decibel is a unit which we use to represent that, or it has been used to compare the sound from one to another, and that is very very helpful for us. Now, when we had started this one, I said this thing as loudness is not able to calculate directly. We have to relate it with something. So over here also, when we are comparing the value of the sound, then we used to take a certain frequency for a sound, and we relate it with the calculation, and we can come to the end of the value that will help us to identify or get the comparison between two different sounds. So जब हम लोग कोई भी तरह के साउंड को कैलकुलेट करते हैं, जब भी हम लोग लाउडनेस को एक्सप्रेस करने की कोशिश करते हैं, तो हम लोग ये ध्यान रखते हैं कि जो हम लोग फोन लेते हैं, यानी जो लाउडनेस की जो उसकी यूनिट लेंगे, उसको हम लोग एक सर्टेन साउंड से कंपेयर कर सकते हैं. तो वो साउंड कौन सी होती है? तो वो होती है एक सर्टेन फ्रीक्वेंसी जिसको हम लोग लेते हैं 1 किलोहर्ट्ज. तो 1 किलोहर्ट्ज का जो साउंड प्रोड्यूस होता है, या इतने फ्रीक्वेंसी से जो साउंड प्रोड्यूस होता है, उसको हम लोग बेस यूनिट मानते हैं, और इसी बेस यूनिट के बेसिस पर ही लाउडनेस को डिटरमाइन किया जा सकता है या फिर कैलकुलेट किया जा सकता है. तो हम लोग मान के चलते हैं कि ये हम लोगों की बेस इंटेंसिटी है. ये बेस इंटेंसिटी है, और इस बेस इंटेंसिटी के लिए अगर हमको लाउडनेस को शो करना है या लाउडनेस को एक्सप्रेस करना है, तो मेरा फॉर्मूला हो जाएगा L इक्वल्स टू the log value, sorry, the k log value of that I. Okay, so the log value जब लेंगे यहाँ पे, तो किसका लेंगे, तो log 10 का लेंगे, तो log 10 with I ले लेंगे। और ये हम लोगों को दिखा रहा है 1 किलो हर्ट्ज के फ्रीक्वेंसी को दिखा रहा है जब ये एक सर्टेन इंटेंसिटी है। तो ये एक रेफरल वैल्यू है, इसको हम रेफर करते हैं, और इसके रेफरेंस से हम लोग लाउडनेस को कंपेयर कर सकते हैं या लाउडनेस को आइडेंटिफाई कर सकते हैं। तो ये मिनिमम लाउडनेस है, जो सबसे कम लाउडनेस के बेसिस पर जब हम लोग देखते हैं, तो इसको बोला जा सकता है कि दिस इज जीरो, दिस इज जीरो, बिकॉज व्हेन वी कम फॉर द कैलकुलेशन ओवर हियर, दिस इज मिनिमम वन। बट व्हेन वी से जीरो, इट इज कंप्लीटली इट इज नॉट कंप्लीटली करेक्ट टू से, क्योंकि देखो जब भी कहीं पे भी साउंड प्रोड्यूस हो सकती है, तो उसकी लाउडनेस कंप्लीट जीरो तो नहीं बोला जा सकता है, तो उसको हम लोग एकदम मिनिमम वैल्यू लेकर चलते हैं 1 के बेसिस पर। तो जब हम लोग कैलकुलेट करेंगे, तो इस 1 किलो हर्ट्ज इज इक्वल्स टू इंटेंसिटी आई, जो कि एकदम मिनिमम साउंड, जैसे कि फॉर एग्जांपल स्टूडेंट्स को टीचर्स बोलते हैं पिन ड्रॉप साइलेंस। सो डू द पिन ड्रॉप डजंट क्रिएट एनी साउंड? No, it is not like that. Pin drop also causes sound. So then we are comparing the sound over there. We are saying, when we say that pin drop silence, it means that there should be no any louder sound. There will be maybe there will be a little bit of sound, but it is not so very loud that it can be aggressive or something like that, that we will be getting irritated because of that. Okay, so that is the minimum value which we used to take. Now with this, if I need to go for the comparison, if I am going to compare this sound with some other sound, then how could I write it for that, or how could I do for that one? So say as for example, I'm comparing the sound with the value, say as for example 1. Okay, and then I will name this one as 0, and over here also it will be 0. So if I will compare one more sound, which is L1, then I can write it as K log 10 and I1. So this is the sound I am going to compare. I'm going to create a comparison, and with this comparison, I will be able to understand that how much louder this sound is there. So we are going to compare the value, and when we go for the comparison, we need to subtract it out. So if I say that there is a louder sound, and that is equals to L1 minus LO or L0. So the log's value, I'm going to place it as that is K log 10 I over here, that is 1, minus K log 10 I0. Now I will take K as a common from here. So I'm getting over here log 10 I1 minus log 10 IO. Now, according to the logs rule, I'm just going to change over here. So this is going to be log 10 I1 by IO. So this is the simple concept. And with this value, if I say for the minimum sound, if I say for the minimum sound which has been produced, that is, as just now we had discussed, that is 1 kilohertz, if it has been produced over there, then that has an intensity of 10 to the power minus 12 watt per meter square. And this is the minimum value which we are taking for the intensity. Under that situation, the loudness will be considered to be this value. And with that one, we will be able to do the calculation of any other comparison also. So suppose we have to find out any other sound, or we need to compare any other sound, and then we can say that how much loud it is. And why I'm saying again and again comparing, देखो comparing यहाँ पे करने का मेन मकसद क्या है, या फिर उसकी जरूरत क्या है? असल में होता क्या है, क्योंकि हम इसको पहले भी तुम लोगों के साथ डिस्कस किए हुए हैं इसी क्लास में, कि लाउडनेस एक फीलिंग है जो कि कंपेयर करके आइडेंटिफाई किया जा सकता है। अलग अलग लोगों के लिए जो लाउडनेस है वो अलग अलग हो सकती है, बिकॉज ये सेंसेशन के ऊपर डिपेंड करता है। तो अलग अलग लोगों की सेंसेशंस अलग अलग हो सकती हैं, जिसके बेसिस पर जो लाउडनेस ऑफ द साउंड होती है वो भी वहां पर अलग अलग हो जाती है। तो हम लोग जब भी कंपेयर करेंगे, तो कंपेयर करके ही लाउडनेस को कैलकुलेट किया जा सकता है। तो एकदम मिनिमम वैल्यू में जो लाउडनेस कैलकुलेट होकर आएगी, ये जैसे कि एकदम मिनिमम वैल्यू की लाउडनेस कैलकुलेट होकर आ रही है इस रेंज पर, तो इसका अल्टीमेट वैल्यू क्या हो सकता है? सो ओवर हियर राइट नाउ वी केम टू नो दैट लाउडनेस इज इक्वल्स टू K log 10 I1 by IO. Now, if we assume this proportional constant as the value of 1, then what it will be? It will become as a log 10 I1 by IO. This is the calculation. Now if I will do some changes over here, okay, I'm going to change over here a little bit. So what I'm doing, I'm multiplying and divide it by 10. Okay, so log 10 I1 IO multiply by 10 and then divide it by 10. Okay, so why I'm doing so? Because I want to change this quantity with a particular unit. Okay, what is the unit? See, when we come for this one, it is called to be bell. This is called to be bell. This is the intensity value which by which we can compare that how much sound is going to be there or how much louder the sound is there. But if we want to make it more specific, if we want to go for more specific situation, then we can compare this one with this 10th value and we can write it as 10 log 10 I1 upon IO, and here this 1 by 10 will be outside. So what does this 1 by 10 is showing? So see, the bell which is we are doing over here, 1 minute please, I'll just correct this one out. Yes, so the bell which we are doing, that you can consider it for as meter. Okay, you take it as for meter. So जैसे कि हम लोग मिली सेंटी डेसीमीटर करके यूनिट्स में आते हैं, ठीक उसी तरह से समझ लो कि ये बेल जो है ये मीटर का लिया जा रहा है। क्यों? क्योंकि हम लोग इंटेंसिटी को मेजर कर रहे हैं, इंटेंसिटी का यूनिट में आता है मीटर, तो इसलिए यहाँ पे जो बेल की अल्टीमेट क्वांटिटी निकल के आई है वो निकल कर आई है मीटर। तो अगर हम लोग इसका 1/10 कर देते हैं, 1/10 ऑफ बेल कर देते हैं, then we can say that it is decibel. Okay, it is decibel. So over here we are having this 1/10. This 1/10 is showing as the decibel. So we can say it as, now we can say this thing, just a minute, I will change the color over here. So over here, this 10 log 10 I1 by IO is considered or is taken as the decibel. So it is a pure unit. It been converted to a pure unit and it became as the decibel. So this is the unit by which we can compare out the sound, and with that one we can be able to establish a relation between the intensity and the loudness of the sound. Now when we will go for the calculation of the sound, then the multiple of 10 will be present over there, and whatever the quantities we are going to calculate, with that one we can easily identify it out. That's why we had changed this quantity. Such as, for example, if we say that the value is like this, just a minute, I will clear it out over here. So just now, as we had understood this thing, that the unit converted to 10 log 10 intensity of the first sound with the minimum intensity over there. So suppose for example, the new intensity is say to be as 100. If it is 100, so now I can write it as log 10 100. And you all know for this thing that the calculation of this one will become as 2. So what it will be? It become as 20 decibel. So like this, we can be able to establish the relation, or any other value. So intensity of the sound becomes as say as 10,000. So if it is 10,000, then you know how it has to be changed. So you just have to place it out 10 log 10 I1 IO, as again IO is the minimum value. We are just which is having a value of 1. I'm repeating this thing. This is a value of 1, and this I1 is the sound which has been produced. So suppose for example this sound is having as this one, that 10,000. Okay, so what can I write it as? That log 10,000, and when we will simplify this quantity, we will get it as 4. So it will be 10 into 4, it will become as 40 decibel. So when we are writing for the decibel units, you will observe that it is always in the multiple of 10. So why it has been in the multiple of 10? Because we had already changed it to deci unit, and that deci unit help us to give the comparison of the sound. So like this, we can be able to compare this different sounds, the loudness with respect to the intensity of the sound. So this is the unit which you need to calculate for understanding the loudness. Okay, now we will move to the next part. So that was the calculation of the loudness with respect to the intensity. And now we are moving to the pitch. So what is pitch and how we can go for this pitch? So again, pitch is not new for you all. You know for this thing that when we compare the sound as for the shrill sound, or as for not to be shrill, that is called to be as the pitch. यानी उस तरह के sound जो कि जिसकी जिसकी shrillness ज्यादा हो, यानी जो जो साउंड काफी पतला होता है सुनने में, उसको हम लोग कहते हैं एज अ पिच, या पिच ऑफ द साउंड एज पर टू द क्वालिटी ऑफ द साउंड, एंड दैट इज डिपेंडिंग ऑन द फ्रीक्वेंसी. ये बेसिकली जो है वो फ्रीक्वेंसी के ऊपर डिपेंड करती है. और फ्रीक्वेंसी अगर हाई रहती है, फ्रीक्वेंसी हाई होने का मतलब क्या हुआ, नंबर ऑफ ऑक्सिलेशंस ज्यादा हैं. तो अगर नंबर ऑफ फ्रीक्वेंसीज ज्यादा, नंबर ऑफ ऑक्सिलेशंस ज्यादा हैं, फ्रीक्वेंसी ज्यादा है, इट मींस कि दैट द साउंड इज ऑफ अ हाई पिच, यानी साउंड वहां पर हाई पिच की है. And that would be very shrill in sound. Okay, you can hear it in a very thinner manner, such as for example when the voice of an woman, or the baby, the infant baby is crying, so that is of a high pitch. And when we come for the low pitch, then the low pitch is a kind of sound where we used to observe this thing that the frequency is less, or the sound is little bit heavier to listen to the observer. So when you are listening to the sound which is little heavier, such as for example the voice of a man is talking, so that is of a low pitch, means the frequency is low over there or less over there. And if the frequency is high, then we do observe that the pitch is also going to be high, means it will be a very shrill sound. So I'm doing for this thing a little bit quickly, because we had studied all these things earlier. Next, we know for this the timbre and the quality of the sound. That is again a property which is known to us. We had studied this thing in our previous classes also. Then also just let's have a little recap of that. So over here, when we come for the timbre or the quality of the sound, it is the basic character of the sound which used to be produced from the source, and depending on what kind of source it is there, such as when we can hear the voice of different person, then we can understand that the different voices used to be different in nature, because they used to be produced with the different frequencies, and different characters are there. And due to that, we can easily recognize different kinds of sound which has been produced around us, such as for example when at your family, when you can hear the sound of any person to whom you are not looking directly, but then also you can easily recognize the voice. How you can do so? You are able to do so because the voice do have some specific character, some specific tendency, and due to that you can easily identify it out. So when we come across two different or more than two sounds with the same amplitude and the same frequency, then also we can recognize the sound as a different nature because of its own specific character by itself. Such as for example, if you have been turned back, and there are two musical instruments such as a guitar and a harmonium been played with the same amplitude and the same frequency, you can easily identify that which sound is of which instrument. That is because both the instruments do have a character of producing sound in a specific manner, and that gives it that particular quality. So over here, we can come across the basic differences between the loudness, pitch, and the sound. So once again, the loudness is the sensation that is mainly depending on the amplitude. There are some other factors also. The pitch of the sound, that is the shrillness of the sound or the flitter of the sound, which is directly dependent on the frequency. And the quality of the sound or the timbre of the sound is actually the sound which we can recognize by distinguishing two or more different kinds of sounds with the same amplitude, with the same frequency, depending just on the basic character or the formation of the sound which it used to produce over there. Now we come to the end of this chapter where we are going to understand about the noise and music. So basically, whenever a sound been produced, if it is produced in a very regular manner with a right condition, with a right format, then we can say, or we can understand that the sound is pleasant to listen, and that is considered to be as music. But if the sound has been produced without any pattern, if the sound is having an random condition, and it is not having any regular note, so then we can consider it as a noise, and noise can lead to noise pollution also. So this is one of the kind of pollution which is without any kind of impurities or any kind of pollutant. When this noise used to reach to different places, or we come across with this noise, then we can go through different kinds of mental disorder or something. Some irregularities can be observed, such as, for example, sleeping sickness can be there, there can be insomnia, or there can be danger to our ears, or continuous headaches can be there, or migraines can cause. So sleeping disorders, which is a very regular or a very common thing which we can observe for the condition of noise. So this is the basic difference which we can create between noise and music. So once again, music is very much pleasant, we like to go through music. But noise, no one wants to have noise, because noise is irritating, and that creates problem for our own ears. So these were the things which we had to discuss. I hope that it was a very easy chapter for you all, because most of the topics you had already studied in your previous class. And even though if you have any kind of doubt or any kind of problem, then we can discuss it in the class, and with that we can come we just come to the end of this chapter. And I will wish you all that you all go through all these topics properly, and wherever you need for the notes, so you can visit to our website, and over there you can get the PDF of this chapter's note. So thank you everyone, we will meet in again in a new video. Thank you for now.